Welcome to Study Loop.
Okay, so the force between the rocket and the Earth is the gravitational force in this form, and it's a centripetal force, so it's going to be equal to mv squared over r. R is the distance between the rocket and the center of the. R is the radius of the orbit. Okay, so from this equation, we know that the velocity squared is equal to g m mass of the Earth divided by the radius. And the kinetic energy is half mv squared. So it's going to be, we use this expression, get into here. So it's going to be g mass of the rocket, mass of the Earth divided by double radius. Now we'll plug in the mass of the rocket, Earth, and the radius. We'll get that the initial kinetic energy is 1.38 times 10 to the 11 joules. And this is the final kinetic energy is 1.13 times 10 to the 11 joules. So the change of the kinetic energy is negative. As you can imagine, looking at the expression here, with a larger radius, you have a smaller velocity. Smaller velocity means smaller kinetic energy. For question B, the potential energy is negative g mass times mass divided by the radius. Again, we plug in the numbers. We have the initial potential energy is negative 2.77 times 10 to the 11 joules. And the final potential energy is negative 2.26 times 10 to the 11 joules. The change of potential energy is positive. So for the last question, the work done, so the work changed the total energy of the system. So it's the sum of the change of the system. So it's basically the change of kinetic energy plus the change of potential. It's going to be 2.51 times 10 to the 10 joules.